Alright everyone, in this video we're going to be going over finding the area of different polygons on a coordinate grid. So recall the area of a figure is just the space that it takes up on a grid. In other words, you guys might have more commonly thought of this idea as all of the space inside of a figure. And also just remember that the units for area, they're always squared. Now the reason they're squared is because there's two dimensions. So think about like base times height or length times width. You are multiplying two dimensions by one another. That's kind of a helpful way to remember that your units are always squared, whether it's inches, feet, centimeters, or even just units. You always have to have that little squared at the end when you're talking about area. Now, these are just some general area formulas, and what I recommend doing in your notes. You guys can see that I've specifically highlighted the base and the height, or the length and the width, or the diagonals in different colors. So I would pick, maybe if you have blue and red, or pick two colors, and you guys want to kind of pause and make the same highlights that I've done. So for a triangle, we have A equals 1/2 of base times height. Now this can be rewritten when you have this 1/2 in front. You guys know that that's the same thing as taking the base and the height, multiplying them, and then dividing that whole thing by 2. So the base is usually the bottom of your triangle, and then the height is going to come from a vertex, and it's going to make, remember, a height of a triangle has to make that 90-degree angle. Now for a parallelogram, again, now we see that base and the height again, but we're not dividing anything by 8. It's just area equals base times height. Now the base is this side right here, and I realize I'm doing red when I should be doing blue, but the base is like this side down here. You can also use this other side as the base, right? Since it's a parallelogram, you know that the opposite sides are congruent anyway. So whether you use this bottom side here as the base or the top side there as the base, it doesn't really matter. But this is where it gets a little tricky. Your heights come from kind of creating that right triangle. So this would be one possible height, and they're going to be the same, right? So this segment could be the height, or this segment could be the height. They're going to have the same exact value. Now for your rhombus, your area is, you do 1/2 times, and then you do diagonal 1 times diagonal 2. Now again, when you have that 1/2 out in front, it's the same thing if you want to take both diagonals and multiply them first, and then divide by 2 in the end. If you're more comfortable seeing it that way, then you can totally do that. And your diagonals, remember, those just connect opposite vertices of your shape. So here in red, we have diagonal 1, and then in blue over here, or sorry, that's diagonal 2, and in blue we have over here diagonal 1. It doesn't really matter which you call diagonal 1 or 2, because you're going to multiply them anyway. And then last but not least, for rectangle or square, we have area is length times width. Where our width, it doesn't really matter again which one is length or width, because when you multiply them, you're going to get the same answer regardless. But just make sure you are comfortable identifying these dimensions. And you're going to have to remember these area formulas as well. The only area formula that's given to you, I believe, is parallelogram. So the only formula that you're given on your reference sheet is this one. So for rhombus and for triangle, you're going to have to kind of remember those. Now, it kind of helps with rhombus too, though. If you don't remember the formula, what you should see is that there are 4 smaller triangles in here. So if you do forget the area formula for rhombus at least, you can kind of use your knowledge. And if you know your diagonals, you'll be able to find each portion, and then you can find that area and then just multiply it 4 times. All right, now there are a couple of different types of examples where they're going to ask you to find the area. Now these are the most basic types of examples where you're going to be able to clearly just count the boxes to find the dimensions. So there are 3 examples up on the screen. So the first one is a triangle, so we know that that is base times height divided by 2. So we can easily count our base is 1, 2, 3, 4, 5, 6. And then our height, if we count the boxes there, we have 1, 2, 3, 4, 5. So our height is 5 and our base is 6. So we have 6 times 5 divided by 2, which would give us 15 units squared. Now these other 2 examples, I won't go through them in as much detail, but again, it's the same idea where you know your shape, you know your area formula, and you're just using the coordinate grid. If the lines are perfectly, or the segments are perfectly horizontal or vertical, you can just count to find the dimensions, and then you substitute those into the formulas. Now here's where it gets a little bit tricky, where we're not going to be able to clearly count the boxes. We're going to have to use some of our other prior knowledge to get some of our dimensions here, because if we don't have the dimensions of the shape, then we're not going to be able to use the formula. So let's start by plotting our points. So t is 9, comma 3, which is going to be here. And then we have u is 1, comma 2. V is -3, -5. And then W is 5, -4. So here is our figure right now. And it's a rhombus, and we want to find the area. So the area of a rhombus is equal to, we have to take our diagonals, so diagonal 1 times diagonal 2, and then we divide that by 2. Now, I'm going to go ahead and draw my diagonals in a slightly different color. So let's say my first diagonal is TV. We'll do that in blue, and then my second diagonal, let's do in this purple-ish color. Our next diagonal is going to be UW. So, we need to find the lengths of these diagonals, but we can't, like, it's not perfectly horizontal or perfectly vertical, so we're going to have to use some other knowledge here to help us find these dimensions. Now, one option, and we'll do this, I guess, for TV. So we need to find the length of TV first, because that's our, I'll call that my diagonal 1. So remember, one option is to use the distance formula to find lengths of segments on a grid. And the distance formula, again, I like to just write the square root. I write my bubbles in here. Oops. I know those are squared. And then it's minus, plus, minus. And then you can go crazy. x2 minus x1, y2 minus y1. So I'm going to go ahead and use the distance formula for TV. So T is 9, 3. V is -3, -5. And then we can label. And then we can just substitute. So D equals the square root of, we have x2 is -3 minus our x1, which is 9, squared, plus our y2 value, which is -5, minus our y1 value, which is 3, and we are squaring that. Now again, I like to simplify my parentheses before I square anything. So -3 minus 9 is -12 squared, plus -5 minus 3 is -8 squared. And then when we square a negative number, remember that our result is always positive, because when you multiply a negative times a negative, that's going to, again, turn positive. So we have 12 squared, or -12 squared is 144. And then we have -8 squared is going to be 64. And then if we add those up, I believe we get radical 208. Now, I might be wrong here. I did mental math there, but hopefully not. We have radical 208. And then the other method that we talked about to find lengths of segments on a coordinate grid, and this would be to find UW, is using Pythagorean theorem. Now, for Pythagorean theorem, you have to make yourself a right triangle. So if I'm trying to find UW, I'm going to kind of go from these 2 points. I'm going to go down here, and then I'm going to go here. And if we count our boxes to find the dimensions of our triangle, we'll have 1, 2, 3, 4. And then this way we'll have 1, 2, 3, 4, 5, 6. So now my right triangle looks something like this, where we have 4, 6, and then we're looking for this value right here. So we get a squared plus b squared equals c squared. 6 squared plus 4 squared equals c squared. Remember, this hypotenuse here always has to be c. So we get 36 plus 16 equals c squared. 52, I believe. Yep, 52 equals c squared. And then we have to take the square root to find our diagonal. So our diagonal, UW, is equal to radical 52. So now that we have the lengths, and again, we label that as D2, so our area formula, and this is going to come from here, right? Now, our diagonal 1, which is what we found in blue, is radical 208 times our second diagonal, which we found in this purplish color, was radical 52. And then we're going to have to divide all of that by 2. So when you plug this into your calculator, you want to make sure you're very mindful of how you're typing it in, because it really can affect your answer. So I'm going to use parentheses to make sure that my numerator stays in the numerator. And what you can do is type in radical 208. And then I'm going to use this arrow here to make sure I'm out of my square root symbol now. So radical 208 times, and then again, times radical 52. And again, I'm using that arrow to ensure that I am outside of that radical now. And then all of that's going to stay in a set of parentheses, and then we're going to divide all of that by 2. And that is our answer. So we have equals, and we got just 52. But be mindful, it's units squared. Never forget that. Always write it to be safe, and always box our answers. If you did not write in the parentheses, just like I did here, you're going to get a totally different answer. So you want to make sure your numerator stays all together, so you put everything in your numerator in parentheses. And be very careful when you're typing this in, because people make calculator errors all the time, and then, we get the wrong answer. So this is the last type of example where you're going to be finding the area of a triangle where the dimensions are not clearly determined. So this process is a little bit different. So let's start just by plotting. So x is -7, -7. Y is -4, -5. And then z is -6, -4. Okay, so here we know that the area of a triangle is base times height, right? And we know that the base is usually like this bottom side here, and then the height we would have to draw from this vertex and go down and make a 90-degree angle. But none of that is going to be easy for us to count at all. Like it's impossible. So in this case, we have to manipulate our diagram, and what we're actually going to do is create a rectangle out of the shape that we already have. So in order to do that, it's almost like the same process as if we were to like use the Pythagorean theorem to find our side lengths here. It's the same exact idea. So what you're going to do is, let's start with these two vertices. I'm going to create that right triangle right there. And that right triangle has dimensions. We have 2 and we have 1. And I'm not quite there yet, so I'm going to choose a different color, this purplish color, and then I'm going to deal with these 2 points right here. I'm going to make a right triangle going down, and this one has dimensions of, we have 2 and 3. And we still don't quite have a perfect figure, and the reason we're doing this is to kind of create a shape that we are used to, that our minds and our brains are used to seeing. Lastly, we have these 2 points here, so we're going to make this right triangle. This right triangle has dimensions of 3 and 1. So now what you should actually see is a rectangular figure. It actually turns out to be a square because all the sides are going to be the same. But if we highlight around all of these sides, we know how to calculate the area of that, right? So the idea is find the area of the bigger figure, and I'll just redraw it just for you guys to get a conceptual idea here. The idea here is to find the area of the entire figure, which we know how to do. And then what's actually going to happen is we're going to slowly start by erasing the area of all of those triangles that we made. So we'll start, and you know what? I'm going to leave it all shaded so you guys can see an idea of what's going on. So first, let's find the area of the square that we've created. So the square that we've created, if we redraw it, it has side lengths of 3, 3, 3, and 3. So the area of a square or rectangle is equal to length times width, which in this case is just going to be 3 times 3 is going to give us 9 units squared. So I know the entire area of this whole shaded region, which I'm not going to shade because it's going to mess up our picture, but let's pretend it was the area of this whole shaded region is 9 units squared. Now what we're going to do is slowly erase the areas of the triangles that we created. So let's find the area of this blue triangle. And again, area of a triangle is base times height over 2. Now, when we create our right triangles, we already have the base and the height. So the base is going to be this 1 right here. The height is 2, and then we're dividing that by 2. So we get 2 over 2. So the area of that blue triangle is 1 unit squared. And what we're going to do is we start with 9, right? That's the area. We're going to take the area of the square, and then we're going to subtract the area of all our triangles. So first, the area of the rectangle, or the square, is 9, minus the area of our blue triangle, which was 1 so far, right? So essentially what's happening right now is we are erasing this blue triangle from our shaded region, right? And eventually all we want to have is the shaded region of this triangle. That's what we want to get, right? So we're almost there. We got to keep going though. So let's go purple. Let's find the area of Our purple triangle, that's again base times height over 2. So our base, in this case, I'm going to take it, doesn't really matter what you choose when you have a right triangle. We're going to have 3 times 2 over 2, which is going to give us 6 over 2, and we get 3 units squared. And then if we add this to our little equation over here, we have minus the area of this triangle. It's going to be minus 3, right? And again, what's happening here is now we are taking this right triangle away from our shaded region, and we are almost there. We have one more to do. So the last one is that blue, that turquoise-ish triangle. And the area of that triangle is going to be, again, base times height over 2. And we have 3 times 1 over 2, which gives us 3 over 2, 1.5 units squared. And now we're going to subtract this again. Oops, that should be an A. We're going to minus 1.5. And now what's happening here, last but not least, I know my picture's a little messy, but what's happening is now we're erasing that portion, and we are kind of, it's not as great looking, but essentially what we're left with is the area of that shaded region of that triangle that we wanted, right? So when we do this math, 9 minus 1 minus 3 minus 1.5, you can put this into your calculators. I believe it's 3.5. So the area of that triangle is 3.5 units squared. So there might be times if you have to find the area of your triangles, like in all the questions for learning target number 3, you're going to have to kind of do this where you're manipulating the figure, making it a familiar shape, which is going to be a rectangle or a square, and then you're subtracting the area of all the triangles within it. All right. So don't forget to always plot your points, figure out the shape that you're using, and then use that area formula cheat sheet for now, and hopefully that will help us remember these formulas.